Hello, this is 7-4 multiplying special cases. We're going to be multiplying binomials, but special binomials. Okay, the first concept we're going to look at is when we square a binomial. In other words, you're multiplying it to itself. If we square the sum of two terms like we do here, if you'll notice, the first term and the last term are squared, and that's here. But the middle term is gotten by multiplying 2 by the a times the b. Okay, so the first term we square a, for the last term we square b, and for the middle term we multiply 2 times a times b, and it gives us a trinomial when we square this. So for an example, if we square this term, we're going to square the x and the 4, we get x squared and 16, but the middle term you multiply 2 times x times 4, and 2 times 4 is 8x, and that gives us that. If we have the difference of two terms and we square it, it changes the sign. It changes this sign, the first sign. Last sign stays positive because you're squaring that. But this sign right here is it becomes a negative instead of a positive. So still we have the square of the first and last terms and 2 times the a and b. So in our example here, we square x, we square -3, we get 9. And then here we multiply 2 times -3 times x, and we get -6x. We're going to look at those two concepts in depth, and one more before we finish this lesson out. In the first set of examples, we are simply going to practice squaring binomials. Okay, for the first one, x plus 8 squared, I'm going to square the first term, x, and square it, you get x squared. Then it's 2 times 8 times x. That gives us 16x. It's positive. And then square the last one, we get 64. And you are finished. It's that easy. Okay, let's move down. Here, this is a difference. X minus 7, so we're going to square x and get x squared. We're going to have a minus sign there because it's a difference. And then we're going to multiply 2 times 7 times x. That's going to be 14x. Then we're going to square the 7 and get 49. Okay, moving to the third one in this row or column. Square the first. We're going to get 4x squared. You have to square the number and the variable to square it. We're going to multiply 2 times all that stuff. So I get 2 times 2 times 3. That's going to be 4 times 3, which is 12. And I get an xy with that because it's 2x times 3y. So we get an xy with that, and that's plus. And then the last term is squared, 9y squared. 9y squared. Okay, this column, top one, square the first, you get 4y squared. We got a minus sign, so put a minus sign there. Then we're going to multiply those two things together and multiply by 2. 2 times 3 is 6, times 2 is 12. We get a y, and then square the last term, we get 9. Okay, second one in the column. Square the first, you get 4x squared. 2 times that, well, that's going to be 4 times 9, that's going to be 36x. And then square the last one, you get 81, plus 81. Okay, keep going. The last one in this example set, square the first term. We're going to get a positive 9x squared. Okay, the middle term, you multiply 2 times that times that. It's going to be a negative 30x. 2 times -3, well, it's -3 times 5 is -15 times 2 is -30. There's going to be an x with it. And then square the last term, you get 25. Okay, and that is squaring binomials, example set 1. In example 2, we are looking at our lone word problem in the example set, and what we're looking at is trying to find the area of this shaded region. This is apparently an outdoor patio. We have a walkway that goes around it that is 4 foot wide all the way around it, and we have a patio here that is x feet by x feet. Okay, so what we're going to do is find the area of the walkway, and that requires some subtraction. So the area of this big square is what we want to get first. And this distance from here to here is x, from here to here is 4, and from here to here is 4. So the whole distance is simply x plus 8. And to get the area of that, you multiply the length times the width. Well, it's x plus 8 this way, x plus 8 this way, which is x plus 8 squared. Okay, for the area of the square, the small square is just x times x, which is x squared. So we're going to subtract those two. But first we've got to multiply or square this binomial. So you square the first, square the last, if you want to do it in that order. Then the middle term, you multiply 8 times x and double it. You get 16x. Okay, they're both plus because that's a plus in there. And if we're subtracting x squared, you subtract like terms. So you have this minus this, that cancels the x squared out, and you're left with an expression that is 16x plus 64. And since we're talking about area, that is square feet. 16x plus 64 square feet. And then once, again, this is just a word problem, but once you are able to know the length of this inner square, you can just plug that length in, and that will give you the area of this walkway all the way around the patio. Now we're going to look at a way you can use mental math with binomial squaring. Okay, so if I'm looking at 39 squared, I can rewrite that in my head. I'm going to write it on this. We've got 39 squared, which really equals 40 minus 1. Okay, and we're going to square that. So remember, to get this, you square the first, and you get 1600. 4 times 4 is 16, so 1600. The middle term, you got 2 times 1 times 40, which is 80. And for the last term, you get plus 1. Okay, so 1600 minus 80 is 1520, and you add 1 to that, you get 1521. Okay, might be a lot to do in the old brain, but it can be done. For this one down here, we got 22 squared. That is the same as 20 plus 2. We're going to square that. Okay, you get 400 when you square 20. Then you're going to get 80 when you multiply 2 times 20 times 2. And then you're going to get 4 right at the end there. You square the 2, you get 4. So 484. That one's a little easier to do in the brain. 484 is our final answer. Now these might be kind of tough for you, especially this one. Let's kind of look at that. 80 plus 5 squared, or 90 minus 5. It really probably doesn't matter. I like adding though. If we square 80, we should get 6400. Okay, and then we multiply this and by 2, you get 10 times 80. I get 800. We're adding. Okay, and then we square the 5, we get 25. And so we're going to add these three things together. We get 6400 plus 800, that's 7200, that's 7225. 7225. And to check this, another way of doing this mental math wise, when you have a squaring a number that ends in 5, you square the 5, you get 25. You add 1 to this, you get 9, and then multiply 9 times 8, and that's 72. And that indeed is the answer there. Okay, let's look at 91 squared. Well, that is 90 plus 1 squared. Okay, so I get 8100 plus 180. 2 times 90, 180. I'm sorry. 2 times 90 times 1, 180. And then add the square of the last term there, 1. So I get 8280 plus 1, that's 82, 81 for the square of 91. Okay, 31 squared, that is really 30 plus 1 squared. That gives me 900. And then 2 times 30 times 1 is going to be 60. And 1 squared is 1. Add those together, 961. 961. Okay, for the last one of this group, it's 20 minus 1 squared. You get 400 minus 40 plus 1. Well, 400 minus 40 is 360, plus 1 is 361, and I happen to know 19 squared is 361, so that actually works out. That takes care of example 3. Now we're going to multiply binomials, but we have a something called a sum and difference pattern here. What we have is pretty much the same two terms, only one has a plus and one has a minus, and something really nice happens when you're doing these. So I'm going to do one, not the way we're going to do it, but I'm going to do it the long way. I'm going to show you how we're going to do it after this, and I think you'll see it's pretty simple. So we're going to multiply these binomials. We multiply those two, we get x squared. Multiply those two, we get a negative 9x. Multiply these two, you get positive 9x. And then multiply these two, you get negative 81. Middle two terms, if you'll notice, they cancel out, become 0. I get x squared minus 81. Okay, so instead of doing all of this, just look what we have. The plus and minus gives me a minus sign here. I simply square the first term and square the last term, and I get x squared minus 81. It's that simple. You don't have to do all of this work. You've got to recognize this sum and difference pattern and simply square the first and last term, put a minus sign between them. It's that easy. Okay, so we have a sum and difference pattern here. We're going to square the first term, we get 9y squared. We'll square the last term, get 16, put a minus sign between them. Okay, we see sum and difference here. We're going to square the first term. That's going to be z8. Square the last term, that's going to be x squared, and we're going to put a minus sign between them. Okay, remember when you're squaring and you got an exponent, you multiply. Okay, next one, first term is 6, we're going to square that, 36. Square the last term, m4, put a minus sign between it. Here, square the first term, 16x4. Square the last term, 64x squared, and a minus sign between them. Last one, these went quick. Square the first term, 25x squared. Last term, 9y squared, minus sign between it. And that is it for example 4. In example 5, we're looking at multiplying two numbers together that are the same distance from a number with a factor of 10. We're going to use our sum and difference patterns from the last example to do that. So I'm going to rewrite this. We have, notice these are the same distance from 60, so we have 60 plus 4, 60 minus 4. Okay, again, showing you how you could do a little mental math here. So 60 squared, we get 3,600. 4 squared, we get 16. And you subtract. So 3,600 minus 16 is 3,584. 3,584. Okay, moving on. This is 20 plus 2 times 20 minus 2. So you get 400 minus 4, which is 396. 396. This is 30 plus 4 and 30 minus 4. So you get 900 minus 16, which is going to be 884. 884. Here we have 30 minus 3 and 30 plus 3. We get 900 minus 9. 900 minus 9, and that's going to be 891. 891. Two more. I've got 50 plus 2, 50 minus 2, multiplied together. 2,500 minus 4, that's going to be 2,496 for a final answer. And here we've got 20 plus 5, 20 minus 5. That is going to be 400 minus 25. That is 375. That takes care of multiplying special cases.